Hi everyone! In this video we're going to dig a little bit deeper into probability and do a few challenging examples. So specifically we want to be able to calculate probability using what we know about permutations, combinations, and binomial theorem. So kind of making connections between the topics. So we're going to start with probability with permutations and combinations, and my favorite example is to talk about cards. So in poker, a hand consists of 5 cards, and in a deck of cards there are 52 cards. So we're going to build up to probability by asking how many different poker hands in general are possible. Okay, so first of all, is this a permutation or a combination? Okay, to answer this, you have to answer the question, does order matter? So is a hand of a king, queen, jack, and I'm just going to do 3 for time, is that hand the same as jack, queen, king? Are these the same hand of cards? And they are, because it doesn't really matter what order you put your cards in, it's still the same hand. So this is an example of a combination because order doesn't matter. So in this case, it's a combination, and you have 52 cards to choose from, and you're choosing 5. So that would give you how many poker hands are possible. I'm going to pause the video and calculate this. You should do this on your own. I'll come back with the answer. Okay, you should get 2,598,960 total hands, which makes sense because there's a lot of ways to get different hands if you consider all the suits and numbers and all that good stuff. Okay, so next one is how do you get a flush, or how many ways are there to get a flush? To answer this, you might want to know what a flush is, so I'm going to use my handy dandy Google tool here. If you're unsure, a flush is a set of cards, so 5 cards, that are all in the same suit. Okay, it doesn't have to be in sequence though, so this is a good example. So they're all the same suit. To get this answer, I think it's easier to consider how many ways are there to get all 5, and I'm just going to start with one suit. So how many ways are there to get all 5 hearts? Okay, again, this is combination because the order doesn't matter. Now, we have to consider what's the pool we're choosing from and how many are we choosing. And the easier answer is that we're still choosing 5 cards, but this time we want them to be all hearts. So how many hearts are there to choose from? Okay, well, there's 4 suits in a deck of 52, which means there are 13 cards of each suit. So this is how you would get all 5 hearts. And how would you get all 5 diamonds? Well, there are 13 to choose from, and you're choosing 5. And what about the other 2? What about our spades and our clubs? Again, it's 13 choose 5, and 13 choose 5. Okay, so in order to get each suit, we're looking at a combination of 13 choose 5, but that happens 4 times in a deck, right? There are 4 different ways you can get a flush. So instead of writing it out this way, you can say it's 4 times the combination of 13 choose 5. Okay, so again, I want to plug that in my calculator, see what that number is, pause the video, come back with your own answer. And in this case, if you calculate that, there are 5,148 ways to get a flush. Cool. So the easiest way to figure out a combination in this case, again, is to choose, or to think about what's the pool you're choosing from and how many are you choosing. Makes this a lot easier. Okay, next one. The best possible hand in poker is a royal flush. How many ways can you do this? So what is a royal flush, you ask? Again, we have this handy dandy tool called Google that can help us. So royal flush is a flush, but it's ace, king, queen, jack, and 10. So it's got to be the same suit, just like a regular flush, but it's got to be royal, essentially. Learning something about cards here. So how many ways can you do this? So again, this is a combination because the order of it in your hand would not matter. King, then a queen would be the same as a queen, then a king. Question is, what is the pool we have to choose from, and how many are we choosing? Okay, now this is an interesting question here. For this one, I want to start with what is the pool we have to choose from? So the pool we want to choose from is how many royal flushes there are in a deck. So given the definition of royal flush, how many are there in a deck? And in this case, the pool we have to choose from is 4. There are only 4 ways to get a royal flush. You can get it with each of the 4 suits. Okay, the next part is how many are we choosing? Okay, there are 4 royal flushes. We want one of them. So the way to calculate not the probability, but the amount of ways you can get a royal flush is 4 choose 1. Which for this, I don't even need a calculator. You can think that through. There are 4 ways to do it. You're picking one of them. That means if you kind of calculate it out, there would be 4 ways to do it. So there are 4 different royal flushes. There are 4 ways to choose that. That's why that makes sense. Last question is, what is the probability of getting a royal flush? Okay, so now we're connecting this to probability here, so that's a good review. Remember, probability is like what you want out of the total. It's a really like a not precise definition, but it works. So what we want is a royal flush. How many ways are there to get a royal flush? Is 4. Okay, and the total would be how many total poker hands there are. So there are 4 hands we want out of a total of 2,598,960. Okay, so we want 4 hands out of this total. So that's why it's so rare to get a royal flush. There's only 4 ways to get that hand out of that many total poker hands. Or if you want to say what's the probability of getting a regular flush, it'd be 5,148 hands out of 2 million, so on and so forth, which is a little bit more likely. If you're curious, this is the probability of all different kinds of poker hands. Feel free to pause and take a look at this if you are interested. Okay, now, usually in probability, we write this as a percent, so I'm just going to go over here and calculate that real quick so you really understand what it means to get a royal flush. So if we want to write it as percent, we're going to divide these. And that's a really, really tiny percent. I don't even know what it is. So you can see how unlikely that is. So probability tells us the likelihood of something happening.